if p and q are two polynomials, then the question subtract p from q. So let's write down the question. Subtract p, where p is a polynomial, from q. In mathematical language, this will be written as q minus p. And yet another way of writing the same thing in mathematics would be q plus minus p. So q minus p is in fact addition of q and additive inverse of p. Now what is additive inverse? Like we already know that what is additive inverse of plus 3? Additive inverse of plus 3 is minus 3. So we simply change the sign. While plus 3 is a constant polynomial and its additive inverse is minus 3. And if we take the polynomial, let's say 2m, that's a polynomial of degree 1. And what is if 2m is a polynomial? What is additive inverse of 2m? That would be minus 2m. Then additive inverse is minus 2m. So simply changing the sign, all the signs of the polynomial gives the additive inverse of the polynomial. Let's get started with a couple of questions here. Example. If p is equal to 2x squared plus 1 and q is equal to x squared minus 1, find p minus q. So this is, we can do this question in either writing horizontally or vertically. If we write it horizontally, then p minus q would be written as p. What is p? That is 2x squared plus 1. And now what is q here is x squared minus 1. And what would be the additive inverse of q? If q is here, if we write it separately, if q is equal to x squared minus 1, then changing all the sign will give us additive inverse of q. So this would become minus x squared and plus 1. And now if we add p and minus q, that will give us the required difference of p minus q. But anyways, if we write p here and then the sign minus and then the q is here x squared minus 1, and now this is 2x squared plus 1, and because of this negative sign, all the sign inside the brackets will change because we want the additive inverse of q. And you have seen it here that this minus sign here will cause all the sign changes inside the bracket. So this will become minus x squared and then plus 1. Now just like addition, normal addition, we group the like terms. Here is 2x squared, and is there any other term which involves only x squared? So this is like term, so we group them together. So this would be 2x squared minus x squared, and then the constant terms plus 1 and plus 1. They are like terms, so we can group them together as well, and we can perform the ordinary addition. 2x squared minus x squared would give us just 1x squared, plus 1 and plus 1 would give us plus 2, and that would be the difference of p minus q. Now let's do another example here, and another example would be subtract 2x cube minus 4x square plus 8 minus x plus 8 minus x from 5x4 plus x minus 3x square minus 9. So same thing, if this was to be called P and this was to be called Q, we are required P minus Q, subtract P from Q. So we will be required to calculate Q minus P. Subtract this from, subtract P from Q. Now, solution, P from Q, that's an English statement, P from Q. And how can we write it mathematically? That would be written as Q minus P. Let's write down Q first, and then Q is now 5x4 plus x minus 3x square minus 9, and then minus, and then P is 2x cube minus 4x square plus 8 minus x, and this would give us 5x4 plus x minus 3x square minus 9. And see how this negative sign will affect every sign inside the bracket, because we want the additive inverse of P. So every sign inside will change to give us additive inverse, and this will become like minus 2x cube, and this was minus here, it will become plus 4x square, and then plus 8 will change into minus 8, and this minus x will change into plus x. Now where the bracket is closing, we'll stop there, and now we'll do the ordinary addition. And for ordinary addition, as you have seen in the last lesson, we start with the highest degree term. The highest degree term is x4 here, and we group like terms 5x4, and we would like to write any other term involving x4, but as we can see, there is no other term which involves x4. So let's move onward, and from x4 then we'll move to see if there is x cube there. So there is a term involving x cube. So in order to write in a descending order, we'll write minus 2x cube. Is there any other term involving x cube? No, there is none. So we skip over to x square now, and we collect all the terms involving x squares. Here is one term here that involves x square, and there is another term which involves x square. So let's write them together. Minus 3x square and plus 4x square. We are done with x square. Now we look for the terms involving only x. Here is one term which is plus x, and is there any other term involving x? Yes, this is plus x. And now we look for the constant terms. The constant term here is minus 9 and minus 8. Therefore we write minus 9 and minus 8, and this will give us the, now these are the simple grouping and addition. So 5x4 will come as such, minus x cube will come as such, but because these are two like terms, so we definitely are going to add them, and minus 3x square plus 4x square, two opposite signs, always numbers subtract from each other, so the 4 minus 3 will become 1, x square, we don't write 1, so it will be x square, and remember the answer takes the sign of the bigger number, which is plus 4, so we write plus x square, and plus x and plus x makes plus 2x, and minus 8 and minus 9 becomes minus 17. Two similar signs, numbers will always add, and the result will also have the same sign, mean negative. So this is how we can calculate q minus p. Now let's take another example here, and this time the sum of the polynomials, if you had contributed the $12 and somebody else has contributed $13, then what is the sum? Sum is equal to 25. So if you take if you subtract your contribution, like take away the money you contributed, this difference will give the money that was contributed by your fellow, that would be $13. Similarly, sometimes we are given the sum of polynomials, and from the sum, if we take away one polynomial, then the other polynomial we can get the second polynomial. So the question here right now is the sum of polynomials is is x square plus 2x minus y cube square. If one polynomial is x square minus 2xy plus 3, then find the other polynomial. Then find the other polynomial. So here we have the sum of two polynomials, which is here. That is, if polynomial p and q both were added, their sum was given, that is x square plus 2x minus y square. So solution, if we take away from the sum the polynomial p, this will give us the other polynomial, which is q. So if we write x square plus 2x minus y square, which is sum of the polynomial, take away the first polynomial, which is p, and if one polynomial is x square minus 2xy plus 3, the answer will be the polynomial q. So this we take just like we did the previous question, x square plus 2x minus y square, and now this negative sign will change all the signs within bracket. This will become minus x square plus 2xy and then minus 3, and now it's all about collection of like terms and performing the addition. Is there any other term like x square? They should be grouped together. Minus x square plus 2x Is there any other term involving simple x? No, there is none. So plus 2x will be written as such. Is there any other term involving y square? No, so this will be written as such. And this already has been used here, plus 2xy minus 3. That is this. And now if we simplify, we can see that x square, take away x square will give us 0. 0 plus 2x minus y square plus 2xy minus 3. So this is the second polynomial. In least form, we can write 2x minus y square plus 2xy minus 3. And now one last question. Question number. So this is another example here. Find the value of x minus 2y plus 3z, where x is equal to 2a square minus a cube plus 3a plus 4, and y is equal to 2a cube minus 3a square plus 2 minus 2a, and z is equal to a4 plus 3a cube minus 6 minus 5a square. Now here, if you look at the question, we are required to find the value of this expression, x minus 2y and plus 3z. In fact, this is simple addition of three things: the x minus 2y and plus 3z. If z is given, then multiplying 3 with it is called the scalar multiplication of z with 3. So multiplying z with 3 will give us this component, and here multiplying y with minus 2 will give us this component, and x is same. So if we substitute and we continue performing these operations here, so instead of x we can substitute 2a square minus a cube plus 3a plus 4, so that is x, no problem there. And then minus 2 times y. What is value of y? Value of y is 2a cube minus 3a square plus 2 minus 2a. That was value of y. And now plus 3, and then value of z, which is a4 plus 3a cube minus 6 minus 5a square. So this was value of, as you can see, x minus 2y plus 3z. We have only substituted values of x, y and z in the same expression. Now let's perform these scalar multiplications. This is going to be as such: 2a square minus a cube plus 3a plus 4, and now minus 2 will multiply. Because of this minus here, all the signs are going to change inside the bracket until the bracket closes. And because of 2, every number inside, every coefficient inside will be multiplied with 2. So in fact we are multiplying every number with minus 2. So if we multiply minus 2 with this 2, this will become minus 4a cube. And we multiply this minus 2 with minus 3. We know that minus times minus will become plus. 2 times 3 will become 6 and a square. And similarly, if minus 2 multiplies with this number here 2, so this minus 2 times 2 will become plus 2 will become minus, sign with sign, number with number. Negative times positive will become minus, and 2 times 2 will become 4. And again same, minus 2 will multiply with this, sign with sign, number with number. So negative times negative will become plus, and 2 times 2 will become 4 and a. Same thing, this number plus 3 will multiply inside the bracket with every term, sign with sign, number with number. So plus 3 times a4, this will give us plus 3a4, and plus 3 times plus 3 will give us plus 9a cube, and plus 3 times minus 6 will give us minus 18, and plus 3 times minus 5 will give us minus 15a square. So once we have this, now we start collecting the like terms starting from the highest degree term, and that is equal to, throughout if you look, that is equal to a4. Is there any other term involving a4? No, there is none. So we write 3a4, and in descending order, what is next? That is a cube. So we look for the terms which have a cube here. So this term here, this term here, and this term here, all these three terms have a cube. Therefore we are going to write them minus a cube minus 4a cube and plus 3a plus 9a cube, plus 9a cube. So we are done with the a power 3, and now we look for the terms involving a square. And here is a square, here is a square. These are the only two terms. So plus 6a square and minus 15a square. So we are done with terms involving, and there is one more term here, plus 2a square in the start. So that also should be written here, 2a square. And now we want to find out the terms, which terms involve only a. Here is one term here, 3a. So let's write that down, 3a. And then there is another term which involves a, that is 4a plus 4a. And then there is no other term. And now we just need to take a look on the constant terms. The constant term is plus 4 here, and then minus 4 here, minus 4, and minus 18. So we are done. So if you want to check that whether you have done all the terms, you can count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are 12 terms here, and there should be 12 terms up there. So now we are going to perform that indicated operation, 3a power 4 minus a cube and minus 4a cube. Both the numbers are negative. Therefore, this minus 1 and minus 4 will add up, and this will give us minus 5a cube. and 9a cube will also be added, plus 9a cube is still there. Okay, plus 6a square minus 15a square will give us how much? Minus 9a square, because plus 6 is one is positive, one is negative. The two numbers will be subtracted. So this will be minus 9a square plus 2a square, that is written here, and plus 3a and plus 4a will become plus 7a, and 4 and minus 4 will cancel with each other, and minus 18. Now there is still addition to be performed. You can do this in one step, but if I'm just doing it so that this is 3a 4 and minus 5a cube and plus 9a cube. That will give us, these are the like terms because both involve a cube. So this will be plus 4a cube. Minus 5 and plus 9 will give us plus 4a cube, and minus 9a square plus 2a square will give us minus 7a square, and plus 7a minus 18. So this is how you can calculate the difference. In fact, if you want to calculate q minus p, it's simply like adding additive inverse of p